What's going on, guys? In this video we are going to see how to solve a homogeneous differential equation. Now first of all, how do we find out a differential equation is homogeneous or not? Now for that one you have to look at the degrees. So here we have a degree of 2. All of them has to be in the same degree in order to be homogeneous. So here we have a degree of 1, y degree of 1, x degree of 1. When we multiply, this also degree of 2. So this is a homogeneous differential equation. Now how to solve homogeneous differential equation? To solve the homogeneous differential equation, what we do is we take this part alone. Okay, here let's notice that let's note down that degree is equal to 2 because everything has 2 power. Okay, this is 1 power, but when you multiply, like even if it's different terms, you have to consider when you multiply 2 terms, the power degree is 2. Okay, the next thing is we have to multiply this one by 1 over x of some power in numerator and denominator, y square minus x square, and then y square, actually here this is yx. So we have to decide what power we have to put here. It's based on the degree. Here we have degree of 2, so we have to put square right here. So when we multiply both of them by degree of like 1 over x square, what we are going to get? This is going to be y square divided by x square, and then minus x square divided by x square, that's going to be just 1. And in the denominator we have 1 over x square multiplied by this one, that's going to be just y over x. Now after we turn into this pattern, the next thing is we have to convert everything using this one. V is equal to actually y over x. If we replace all this y over x with v, what we are going to get? So in that way we will get dy by dx is equal to v square minus 1 divided by v. Okay, so this is one of the equation. Now what we have to do is we have to rearrange this one, like y in terms of y is equal to v times x. If I rearrange this one, now if we take the derivative of this one, d by dx v, actually y, that's equal to what? D by dx. If I take the derivative with respect to x both sides, vx, here this is going to be just dy by dx, and in the other side of the equation we will get a chain rule. This is going to be a chain rule. First we will have this v alone, because if I take the derivative of x, that's going to be just 1, so we will have the v alone. And when we take the derivative of v with respect to x, this is going to be just x dv by dx. Okay, now here you can see we have two equations in terms of dy by dx. So what we do is we take these two together and equate. So this one is v square minus 1 divided by v, and we equate this one to this one. This is v plus x dv by dx. Now this is our purpose. We have brought a pattern that is a separable. After that it's easy to solve. Now what we have to do is we just have to separate and integrate. Now how we can simplify this one? We can separate this denominator for both, like v square divided by v, that's going to be just v minus 1 over v. I just substitute this denominator v for both of them separately, like v square divided by v, that's just v minus 1 over v, and that's equal to v plus x dv by dx. Now the next thing is, if you move this v to this side, this is negative, it's going to become negative v, and here we have positive v. This 2v cancels each other. Okay, so we will have 1 over v is equal to x dv by dx. Now we have to bring all the v terms to one side and x terms to the other side. If we do that, since we have dv in the numerator right here, we have to bring this v to this side. So this is going to be v dv, and here we have dx in the denominator. If I bring this x to this small side, this is going to be just 1 over x. Here we already have a negative sign, I keep that one as it is, and 1 over x, and we bring this dx to this side, that's going to be just dx. Okay, now after we separate, we just have to integrate both sides. So let's do the integration. We integrate here, 1 over x dx, this is just ln of x, so this is going to be negative ln of x, and then in the other side we will have just v square divided by 2, and we just add a constant right here. Okay, now the next thing is we know that y is equal to vx, because finally we have to express our answer in terms of y. So y is equal to vx, so here we have to turn this one So v is equal to y over x. This is the best thing to apply, because this is going to become y square over y divided by x whole square. Okay, let's go ahead and apply that one here. Let's use a different color. This is going to be negative ln of x, negative ln of x. So it's better to add the constant to the other side, right? Because finally we have to add a constant. It doesn't matter what is that value is, even if it's negative or whatever it is, it's always going to be a constant. So we can generally put it as a constant. It depends on which side. Like, since we are having y in this side, it's better to put the constant in the other side. Okay, now let's go ahead and substitute this y over x instead of this v. So this is going to become y square divided by x square, and I move this 2 to the other side also. So this is going to be minus 2 ln of x, and then we can move this x to this side. So this is going to be y square is equal to x negative 2x square ln of x. Okay, and we had a constant. Don't forget a constant. We have constant, so we add a constant, and that's enough. That's it, right? And if they ask for y just square root of all of this. But since we have negative, we cannot do that. We can just leave it as it is. This is going to be our final solution for this differential equation. I hope this helps. Thanks for watching. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.